Welcome. This small course is designed for those who have no prior knowledge of Python but need to learn it quickly for a project or a technology that requires it. In a short time, you will grasp the fundamental concepts of Python programming and obtain the foundation to proceed with more advanced tasks and technologies. Let's start. Let's start with variables and data types. Variables are used to store information, and this information can be used and manipulated later, and the data types we will see are integers, floats, strings, and booleans. Integers and floats are numbers, strings are texts, and booleans are true or false values. Now let's see some examples of them. I will define a variable as my integer, and this will be equal to 5. As you see, this is a whole number, this is an integer, and we have assigned its value to this variable, my integer. Okay, let's call my float in here. My float is equal to 3.25. This is a float, this is a decimal number, and we have assigned its value to this variable. Okay, integers are whole numbers, floats are decimal numbers. Let's see an example of a string. I will call greet is equal to, let's say, hi there. Okay, as you see, this is a text, and we have written it into those quotes. You can use double quotes or single quotes, it doesn't matter. When you write something in quotes, it's a string, and we have assigned this string to this greet variable. Okay, booleans can have two values. The first one is true and the second one is false. So I'm going to create a boolean in here. Is valid is equal to, let's say, false. Okay, this is a boolean. This value is assigned to this variable is valid, and now this valid's type is a boolean. We can also do it like this as true. They are starting with uppercase. Okay, now if you want to see something in the console, you need to print it. I'm going to write print, open parentheses, and write, for example, my integer in here. If I run this, I'm going to get 5. I can see this value in the console. And you can also print multiple things by putting commas between them. I'm going to print all the things I have defined in here. My float, greet, and is valid. If I run this one more time, I will get 5, 3.25, hi there, and true. Okay, now let's see operators. Operators allow us to perform calculations and logical operations. There are arithmetic operators for mathematical operations, comparison operators for comparing values, and logical operators for combining Boolean expressions. Okay, now let's see some examples of them. I will start with arithmetic, and I'm going to write total in here. Okay, this will be equal to my integer, as we have defined above, my integer plus my float. Okay, let's also print it at the end of the cell. I will write print total. If I run this, I'm going to get 8.25, which is 5 plus 3.25. Okay, this is very simple. And also, we can write difference in here. Difference is equal to my integer minus my float. Okay, let's also write it into this print statement. Difference, run this, and we'll get 1.75, which is 3.25 subtracted from 5. We can also multiply numbers. I'll call product is equal to my integer times my float. If I run this after putting it to this print statement product and run this, we will get 16.25, which is 5 times 3.25. Let's say division. Division is equal to my integer divided by my float. Okay, let's add it to this print statement. If I run this, we will get this number, and this is 5 divided by 3.25. You can also use numbers directly with those operators. I will write 15 divided by 3 in here. If I run this, I'm going to get 5. But even if this is an whole number, we will get an float. Okay, the type is float. To get an integer as a result of a division, you need to use floor division, and this is done with 2 slashes. Okay, this is floor division, and if I run this time, we are going to get 5, and its type is integer. Okay, but if you try to, for example, divide 16 by 3, run this, you are going to get 5.333. But If you use floor division in here, it's going to give you 5 again. It's going to round the number down to the highest integer. Okay. If I run this one more time, you'll get 5. If you try to divide 17 with 3, you are going to get 5.666. This time this is closer to 6 than 5. But again, if you use floor division in here, it's going to round it down again and you will get 5 at the end of this again. Okay, you'll get 5. Okay, let's see another operator, and it's going to be the modulus operator. Let's write remainder is equal to 16 modulus 5. This percentage sign is the modulus operator and it's going to give us the remainder of this division. So we will get 1 from here if we put it at the end of it. Remainder. If I run this, we will get 1. Okay. And if you divide 15 by 5, since 15 is divisible by 5, you are going to get 0 at the end of this. Those two operators are very useful. And this modulus operator is mostly used to check that if a number is even or odd. Okay. To do this, we are going to write 2 after this modulus. And if the result is 0, you will understand that the number is even. And if the result is 1, the number is odd. Okay, let's run this. Since the 15 is an odd number, we will get 1. But if you try it with 14, you will get 0. So we will understand that 14 is an even number. Now I will show you a different usage of those operators. For example, x is equal to 3. Okay. And you are going to add 1 to x. To do this, there is an alternative to this expression. You can write x plus equals 1. Okay. This is the equivalent of this one. And it's going to add 1 to x. And you can use it with any other operator. For example, let's say y is equal to 4. And let's do it with 3 actually. Doesn't matter. And you can write, instead of writing y is equal to y minus 3, you can write y minus equals 3. Okay. It's going to do the same thing with this one. Okay. And also you can do this with any other operators, as I said, with multiplication, division, floor division. It doesn't matter. Okay. Let's see the comparison operators. I will write is less. Okay. And I'm going to write the integers, the integer and the float I have defined. My integer is smaller than, less than my float. Okay, this is going to check that if my integer is less than my float, then it's going to return a boolean after this. Let's print it. I'm going to print in a new line is less. If I run this, I'll get false. Why is that? Because this was 5, this was 3.25. And 5 is not less than 3.25. Okay, it's very simple. And let's write is greater is equal to, again, my integer, but this time is greater than my float. If I add it in here, is greater, this time I will get true. Let's run this and we will get true because 5 is greater than 3.25. You can also add equal sign. And you can check that if this is smaller than or equal to my float, if it is greater than or equal to my float. Since there is no equality, if I run this, we are going to get the same results, false and true. And you can also check that if two values are equal to each other. And to do this, you need to use double equal signs. Okay, it's going to check that if two values are equal to each other. Okay, let's change it to less than again and continue. Let's see the logical operators. Logical operators are and or operators. Okay, those keywords. Now let's see how to use them. And result, I will call, is equal to, let's open parentheses and write this expression in here. We can also use this is less directly, but I want to do it like this. And I'm going to check also is valid. Okay, we have defined it in here. As you remember, it was true. Okay, it's going to check both sides of this and keyword. If both sides are true, it's going to return true. Otherwise, if just one of them is equal to false, it's going to return false. If both of them are equal to false, it's going to return false also. Okay, let's check this one. In a new line, I'm going to print end result. Okay, this was false, as you remember from here, because 5 is not less than or equal to 3.25. So if I run this, this time this part is false, this part is true. We are going to get false at the end of this AND operator. Okay. Now let's see this OR operator or result. And I write the same thing in here. Okay. In OR operator, just one true statement is enough to get a true at the end. Okay. So this is false, but this is true. Since we are using OR in here, if I run this, we are going to get, we got false. Why is that? Because we didn't print OR results. Let's print OR result also, and we will get true from this OR result. Okay. Let's try to get some different outputs from this AND and OR results. Okay, I will change this to a true statement. Okay, my integer is greater than or equal to my float. This is true, and this was also true. So both sides of this AND keyword is equal to true, and the output will be true. If I run this, we will get true this time. Okay, and result is equal to true. And if I write, if I want to get false from here, from this OR operator, I need to get false from the both sides of this OR operator. This is false. My integer is not less than my float or equal to my float, but this was true. So just change it false directly. Okay, you can also do it like this. And both sides are false now. So if I run this again, I'm going to get false from this OR operator. Okay, for AND, both sides should be true to get a true. For OR operator, you need just one true statement, and this is enough. Okay, this is the end of variables, data types, and operators. Let's start with the data structures. Data structures we are going to see in this course are lists, tuples, dictionaries, and sets. We will start with lists. Lists are used to store multiple items in a single variable. They are ordered, they are changeable, and they allow duplicate values. The changeable feature of a list is departing it from a string and a tuple, and allowing duplicates is departing it from a set. Okay, we'll see what I mean in the later sections of this course. Lists are very versatile and commonly used to store collections of related data. Okay, now let's see how to create and modify lists. I write numbers, this will be the name of the list, is equal to, and to create a list you need to use brackets. Okay, and inside of those brackets I write the items of this list with commas between them. I write 1, 2, 3, and 4. Okay, this is a list. Now let's talk about indexing a little. If you try to reach the items in this list, for example, I write numbers. Actually, let's print it. At the end of this, I will print numbers and index 0. This is how to use indexing, name of the list, and after that brackets and the index you want in here. Okay, the indexing is starting from 0. So if you write 0 in here, let's run this and we will get 1 in here. Why is that? Because this 1 is at index 0, and indexing, as I said, starting from 0, 1, 2, 3, and it's going on like this. Okay, so if I write 1 in here, it's going to give me the second item in this list, which is going to be this 2. Let's run this. You'll get 2. If I write 3 in here, so if you count it from the beginning, 0, 1, 2, and 3, it's going to give us 4. And if you write 4, you are going to get an error because there is no index 4 in this list. It is ending at 3 since it is starting from 0. Okay, let's leave it like this. Now I want to add something to the end of this list. I'll write the name of the list dot append. Okay, this method is used to add an item to the end of this list. I write 5 in here, and if I change this to numbers directly and run the cell, you'll see that 5 is added to the end of this list. Okay, let's see how to remove an item. Numbers dot remove, directly we write remove and write the item in this remove method. Okay, I'm going to remove 2 from this list. So I write 2. This is not the index, this is directly the item itself. Okay, let's run this and we'll see that item 2 is removed from this list. Okay, now let's see how to change an item in this list. To do this, we are going to use indexing again. Okay, let's say numbers at element index 0 Okay. Element at index 0. This is going to give us 1, right? Normally. And after that, I will say that is equal to 10. So it's going to find the thing in this list, 1. And after that, it's going to change its value to the thing I have written in here. So this will be 10, 3, 4, 5. Okay, let's run this. And as you see, we got this new list after this modification. Okay. Now let's see list comprehension. List comprehension is a very practical way to create new lists based on some logic. It might seem a little complicated for you right now, but there is a usage like this and I just want to show it to you. Okay, I write squares is equal to. I want to take the squares of the numbers in this list and create a new list out of this. To do this, I will open brackets and write n squared. These double asterisks are used to take the power of a number. So if I write 2 in here, it's going to take the square of the number n. Okay, n squared for n in numbers. Okay, this is going to tell the program that take the square of every number in the numbers list. Okay, and after that, if I print this squares and run the cell, you'll see that we got a new list and we have the squares of the numbers in the numbers list. Okay, this is this comprehension. Now let's see the list methods. Before that, I want to show you some other features of lists. Here I have created a numbers list again, and I'm going to write print numbers, and I'm going to get to last item of this list. To do this, we can count the numbers starting from index 0, 0, 1, 2, 3, and 4. Okay, the index of the last item in the list is 4. If I do this and run this, I'm going to get 5, the last item. But you can also do this by writing -1 in here. Okay, if I run this, I'm going to get -1. The indexing is starting from 0 from the beginning and starting from -1 to the end. Okay, so if I write -2 in here, I'm going to get 4. -1, -2, -3, and it's going on like this. Okay, now let's see the slicing of strings. With slicing, we can get a portion of the list. Okay, I'm going to write print numbers and write 2 to 4 in here. Okay, if I run this, I will get 3 and 4. What does that mean? It's going to start from index 2, which is going to be 0, 1, 2, and it's going to end before it gets to index 4. Index 4 is this 5, and it's not going to take it. So the first one is inclusive and the second one is exclusive. So it's going to give us indexes 2 and 3. It's not going to give us 4. So it's giving us 3 and 4 in here. Okay, you can also do it like this. For example, you may not want to write anything in here and you can end it at 2. So if you don't write anything in here, it's going to start from index 0 and it's going to end before it gets to index 2. Okay, so it will give us indexes 0 and 1. 0 and 1. This is index 2. It's not going to give us this one. Okay, if I run this, I'm going to get 1, 2, which is indexes 0 and 1. Okay, you can also do the same thing like this. You can start from index 2. And since this is inclusive, this time it's going to take this 3. And after that, it's going to give us all the rest. It's going to give us 3, 4, and 5. Let's run this. And it is giving us this portion of the list. Okay, this is all. Now we can get to the list methods. Python provides us a variety of built-in methods for working with lists. These methods allow you to modify, sort, and analyze list elements easily. Knowing these methods can significantly simplify your code and make it more efficient. Okay, now let's see some of the most commonly used list methods. Okay, I'm going to create the list first. Fruits, going to be a list of strings, and the elements will be apple, banana, and let's say cherry. Okay, let's use this append method again. I'm going to write fruits.append, and it's going to add this melon to the end of this list. Okay, let's print it at the end. I write print fruits. If I run this, you'll see that this melon is appended to the end of this list. Let's see insert method. Fruits dot insert. Okay, and first I will write index, and after that the new value. Okay, I'm going to write blueberry. It's going to add this blueberry to index 1. There was banana. It's going to add blueberry to here, and after that all the items after that will be shifted to the right. Okay, if I run this, you'll see that blueberry is added, but this time banana is not deleted. Okay, it was the case with this one. It was changing the value at index 0 with the new value, but this is not like it. This is going to add the new value. After that, it's not going to delete the item at this index 1. It's going to shift the items after this. Okay, so banana was indexed at index 1, but now it is at index 2. Okay, now let's see another one, and we have already seen it. Fruits dot remove. Okay, I'm going to remove banana from this list. If I run this, it's going to remove banana, and we have this list right now. Now let's see the pop method. Pop method deletes the element at the end of the list and returns it. We have not seen return keyword yet. We are going to see it in the functions, but return means if an expression returns something, you can assign it to another variable and use it in your code. Okay, now we are going to understand what I mean. I'm going to create a variable called last fruit. Okay, it's going to be the last element on the list, which was melon in this case. Last fruit is equal to fruits dot pop. Okay, this is all. If I print the last fruit in here, we'll see that it's going to delete the melon at the end of this list, and it's going to return it. After returning it, we are assigning it to this last fruit. So we will see melon in here, and we are not going to see melon in this fruit list anymore because it's going to delete it. Okay, if I run this, we will see that melon is removed from this list, and now we have its value in this last fruit variable. Okay. Now we are going to see the sort method, but to understand it, I'm going to change this to orange. Okay. And if I run this one more time, this time at the end, in here, in the line here, we have apple, orange, and cherry in our hand. Okay, the list is this. And after that, I'm going to call fruits dot sort. This sort method sorts the list. If this is a list of strings, it's going to sort them in the alphabetical order. If it's a list of numbers, it's going to sort them in the increasing order. Okay, if I run this time, this orange will be get to the end of this list and cherry will be at the index 1. Okay, if I run this, as I said, apple, cherry, and orange. Okay, it sorted them in the alphabetical order. And also we have the reverse methods. I'm going to call fruits dot reverse. Okay, if I run this after sorting it, it's going to reverse the list. So we will see orange, cherry, and apple as our list. Okay, orange, cherry, and apple. Okay, it reversed the list. And we will also see the element count of the list, number of the elements in the list. And we can do it like this. I'll call item count. This is going to be a variable. Is equal to len. This is a function, and I'm going to put the fruits list in it. Okay, this is going to give us the number of the elements in the list. So we will see if I print item count at the end, we will see 3 as the number of the elements in the list. Okay, this is also a very useful function, and we will use it a lot in our programming journey. Okay, now let's see tuples. Tuples are very similar to lists, but they are immutable, so their values cannot be changed after they are created. Tuples are often used for fixed collection of items and can be more efficient than lists in certain situations. Okay, let's create a tuple in here. I write coordinates equal to, and I'm going to use normal parentheses to create a tuple. I write 10 and 20 in it. Okay, after you creating it like this, the program will understand that this is a tuple, and after that I write x is equal to, I'm going to reach the values in a tuple. We can do this. Coordinates at index 0. This is going to be the same with the list. We are using brackets for indexing, and it is going to start from 0. So this will give us 10. And after that, let's say y coordinate is equal to coordinates again at index 1. So this is going to give us the element at index 1. It's going to be the second element in the tuple. Okay, let's print those. I'm going to print the coordinates and also x and y values to check if we are getting the value from this tuple right. Okay, let's run this, and we will see that this is the tuple, and this is the list element at index 0, and this is the element at index 1. Okay, after that, after creating the tuple, I'm going to try to write coordinates at element index 0. I'm going to change it to 30. Okay, I will take this 10 and change it to 30 as we did with the lists. But if I run this, I'm going to get an error. Why is that? Tuple object doesn't support item assignment. So they are immutable. They are not changeable. So we cannot make an operation like this on a tuple. Okay. Let's run this again and get to the dictionaries. Dictionaries are unordered collections of items in the form of key value pairs. They are unordered. The order is not important because we are going to reach the values using the keys. Okay, they are incredibly useful for storing data, and the data can be quickly retrieved using unique key. Okay, let's see an example of it. I'm going to get to here and create a dictionary. Okay, I'll call it person, and I will use curly braces in here. Okay, and after that I will start to write the key value pairs. First key will be name, and to write the value I'm going to write a colon in here, and after that I will write John. Okay, this is the first key and this is the first value, and after that we are going to separate the key value pairs from each other using commas. Okay, so this is like a element in a list and we are separating it with comma from the other ones. Okay, I'm going to write the second key. This will be H, and H will be 10, 30, and let's write the third key in here. It's going to be city, and the value of it will be New York. Okay, this is a dictionary. We can print it. Print person. Okay, if I run this, you will see that we have the dictionary as we have created in here. Okay, after that, let's try to change the age of this person. Okay, I write person, and to use the key to get to the value, I'm going to open brackets in here, and in the brackets I'm going to write the key directly. Okay, age. So I'm going to write 31 in here. If I run this time, as you see, the age is changed in this dictionary. Okay, if this age key is in this dictionary, it's going to change the value, it's going to update the value, but there is no age key in the dictionary. When you call it like this, it's going to add this key value pair as a new key value pair into this dictionary. For example, let's add a new key value pair to this dictionary. Okay, I will write person, and the key will be is married, and the value will be true. Okay, John is married. So if I run this, I'm going to see that is married true key value pair has been added to this dictionary. Okay, we can also retrieve the values from this dictionary. To do this, I'm going to create a variable, and I will call it person age is equal to person brackets age. Okay, this is going to give me this 31. Okay, it was 30 at the beginning, so we have changed it. So if I print this person age, you'll see that we got 31 from here. Okay, this is how to retrieve the elements in this dictionary. Okay, now we are going to see some dictionary methods, and they are special to dictionaries, and there are 3 of them. The first one is keys. Keys is equal to person dot keys. It's going to return an iterable, and it's going to return the keys in this dictionary. Okay, let's print it. Print the keys. And if I run this, we'll see that we got an object like this, and in here we have the list of the keys in this dictionary. Okay, the second one is values. Let's put it in here. Values is equal to, this will be the same person dot values, and it's going to give us the values in this dictionary. Okay, let's change it to values. Run this, and we will get John, 31, New York, and true. And after that, finally, we got the items. Items is equal to person dot items, and it's going to again return an iterable, and it return a different object, and you can use this result. As you see, it is a list. Okay, and in this list there are tuples. Okay, 2 element tuples, and tuples are the key value pairs, so you can use this if necessary in the loops and in the algorithms that you are going to write. Okay, now let's see sets. Sets are unordered collections of unique items, and they are commonly used to remove duplicates in lists. Okay, let's see an example. I'm going to write unique numbers. Okay, this is going to be open braces just as the dictionaries, but I'm not going to write any key value pairs. I'm going to write some items in it. Okay, 1, 2, 3, 4, 5. This is a set now, and after that I'm going to add something to it. Unique numbers dot add, We are going to use add method to add something to a set. Okay, I'm going to write 6 in here. Let's print this. Print the unique numbers. Okay, let's run this and we'll get 1, 2, 3, 4, 6, 4, 5, 6. So it has added this 6 at the end of this set. If I copy this and try to do this one more time, run this cell, I'm not going to get any error, but also it's not going to add this new number to this set because it's the feature of it. It's not going to accept any duplicates. Okay, and after that we can also delete an item from a set. I'm going to write remove and write 3 in here. If I run this, it's going to delete this 3 from this set. Okay, this is how to create and apply some operations on a set. Now we are going to see the set function. Okay, the logic will be the same. I will create a list in here, my numbers, a normal list with braces, with brackets. Okay, I write 1, 2, 3, 4, another 4, another 4, 5, 6, 6, 7, 7, 7. Okay, this is a list. And after that, I want to remove the duplicates from this list. Okay, let's say it's a very huge list, so I don't know which are the which element is passing more than one time in this list. So I write without duplicates. This will be equal to set. This is the set function, and if you put this list with duplicates in the set function, and let's print it at the end without duplicates, we will see that all the duplicates are removed, but we got a set at the end of it. Okay, we put a list in it and we got a set after that, and the duplicates are removed. But let's say I want to remove the duplicates, but after that I want to get a list at the end. Okay, to do this you can take this also in a list function this time. Okay, this will remove the duplicates and return a set, and after that this list is converted to set to a list again. If I run this, I'll get the same result without the duplicates, but the type is list this time. Okay, this is the end of data structures. In this part, we will see control flow statements, which includes conditional statements, if statement actually, and the loops, which are for and while loops. Okay, let's start with conditional statements. They used to execute different code blocks based on certain conditions. Okay, they allow us to make decisions on our code, and they include if, elif, and else statements. Okay, now I'm going to define a condition in here. I write my condition, and this will be equal to true for now. Okay, now I'm going to check if my condition is equal to true with an if statement. I write if my condition is equal to true. Okay, this was the operator, as you remember, to check if something is equal to something. If this is equal to true, I'm going to print something. Look at the indentation. We are now into this if block. Okay, it's not starting from the beginning, it's starting from here. Okay, I'm going to write very basic, it is true. Okay, after that, else, if this condition is not equal to true, we are going to get into this else statement, and the code block in here will be executed. I write it is false. Okay, it is just that actually. If I run this, we are going to see it is true. Why is that? Because my condition is equal to true. It's not going to get into this code block if it gets into this one. Okay, if I change this to false and run this one more time, we are going to see that this code block is executed. Now we can see it is false. Okay, now let's create another example with this and put the elif statement also in this example. Okay, I write temperature is equal to 21 degrees. Okay, I'm going to start another if statement. I write if temperature is smaller than less than 15. Okay, and I'm going to print it is too cold. Okay, after that I'm going to write another if statement in here. To do this, we need to use elif. Okay, this means else if this is not equal to true, we are going to check this one. Okay, I'm going to write temperature is greater than or equal to 15, and temperature again is less than 25. In this case, I'm going to print another thing in here. I write it is a little cold. Not too cold, a little cold. Okay. Now let's put another elif. We can write more than one elif statements in here. We can check more than one thing. Okay. I write if temperature is equal to 25. Double equal signs. If it is equal to 25, I will print it's perfect. Okay. It's perfect. Let's put another elif statement in here. This time I will check that if temperature is greater than 25 and temperature is smaller than, less than or equal to 40. This time I will print it is a little warm. And else I will say there is just one possibility left. It is higher than 40. So we don't need to write anything for this because we covered every other possibility in here. I will write print it is too warm. Okay, now let's run this. Now the temperature is equal to 21. So it's going to get into this elif statement. It's not going to get into this one because this will be false. And after that, it will check that if it is greater than or equal to 15, it's true. And also, if it's going to check that this is also true, it is less than 25. So both sides will be true. And this AND operator will give us true at the end. And we are going to get into this one. Since we are going to get into one statement in here, it's not going to get into any other one. So we are going to directly see this, it's a little cold in here. Okay, let's run this. As you see, we see it's a little cold. Okay, we can change it. We can make it 10, for example. This time it's going to get to this one. So it's not going to check for anything else in here. It's going to print this one and continue. It is too cold. Okay, let's write 25. This will return false. This will return false, but this will turn true. It's going to get into this one and it's not going to continue. It's not just going to print this and continue again. Okay, now let's write 44 and run this for the last time. And we will see that it's not going to get into any one of those. And there is just one possibility left for the temperature is greater than 40. And it's going to get into this else statement. And we are going to see it is too warm in here. Okay, this is if, elif, and else statements, conditional statements. Now we can get to loops. Loops are used to execute a block of code repeatedly. There are for and while loops. For loops are used to iterate over a sequence of elements, so there should be something to loop through. But while loops continue executing as long as a condition is true. Okay, so the structure of them is different. Now let's see. Let's start with the for loop. Okay, I write for I in range. And I write 1 to 6 in here. Okay, this is going to return an iterable from 1 to 5. This is very similar to slicing. This part is inclusive and the second one is exclusive. So it's going to start from 1. It's going to end at 5. Okay, and I will take the value of the numbers in here every time this loop through. So if I print I in here, this one will be executed five times and every time the i's value will be different. Okay, let's run this and see what I mean by that. As you see, we printed I in here, but every time we see a different value. Okay, 1, 2, 3, 4, 5, which are coming from this range function. Okay, let's see another example. After that, after 5 is printed from here, the loop will be ended. So the limits are certain and we can continue from here. Okay, for let's say j this time, in range again, I write directly 4 in here. Okay, as I said, this is very similar to slicing. We didn't write anything at the beginning, so it's going to start from 0 this time and it's going to end at 3. But whatever you write in here, it's going to be the number of times this is going to loop through because it's going to start from 0. Okay, let's print j this time. Also comment this out, see it more clearly. Okay, if I run this, we will see that this loop through 4 times and every time the j's value will be changing from 0 to 3. Okay, it's not going to take this one, it is the limit. Okay, we can also loop through in a list. loop through a list. I'm going to create numbers is equal to, let's say 1, 2, and 3. Okay. And I write for, you don't have to write ij or something like this in here. You can write anything, any variable you want. I write number in numbers. So this will mean that for every number in this numbers list, print the number. So if I run this after commenting this out, if I run this one, you will see that the numbers value is changing from 1 to 3. Okay, it's going to take the values in this list and it's going to print them. You can also do anything in here. We are just I'm just showing you by printing them in the console. Okay, now let's see the while loop. By the way, you can write comments putting this hashtag in here, while loop. I will define a counter for this. Counter is equal to 1. Okay, after that I will write while counter is less than or equal to 5. Okay, this will be the condition to be checked. And after checking this, if this is equal to true, so this will be true for counter is equal to 1. We are going to get into here and we are going to print the counter. Okay, and after that we need to increase the counter, because if you don't do this, it's going to be true every time. So this will be an infinite loop and we don't want this. Okay, I'm going to increase the counter by 1. I will write plus equals 1. As you remember, this is the same with writing counter plus 1. Okay, I want to use the plus equals operator. It is more practical. Okay, now let's comment this out and run this, see what we'll get. As you see, we got 1, 2, 3, 4, and 5. Okay, the counter was 1 at the beginning, so this is true. It's going to get into this while loop and it will print 1 and it's going to increase it to 2. And it will go on like this. After that, it's going to be 4. It will be increased to 5. This will check. It will check that if it is less than or equal to 5, it will be true for the last time. It's going to print 5. After that, it will be increased to 6. Okay, it's going to check this one and this will be false. And after that, the loop will be ended. It's not going to execute the code anymore and it's going to get out of this loop. Okay, as you see, actually for loops are much more practical than the while loops, but sometimes we need to use it, and the most common use case is to use the while true loop. Let's see that. I'll define the counter again. Counter is equal to 1. After that, I will write while true. Okay, this will always be true, so this is going to be an infinite loop. We need to put something inside of it to break out of this one. Okay, I'm going to print the counter when I get into this. And after that, I write the statement in here. I'll check that if counter is equal to 5. If this is equal to 5, break out of this loop. This is a special keyword to end the loop. Okay. If this is equal to 5, we are going to end the loop. But if we are not going to get into this one, we are going to increase the counter by 1. Okay. If I comment this out and run this, we are going to get the same result, but the structure, as you see, is different this time. We are checking the condition inside of this while true loop and we are using this true keyword in here. Okay, now let's see the loop control statements. They are break, continue, and pass. Okay, break exits the loop as we have seen above, continue skips the current iteration and continues with the next one, and pass does nothing. We will see about them in an example. Okay, we can use all of them both with for loops and while loops. I'm going to use a for loop in here. For number in range, I will write 1 to 11. Okay, so this will start from 1 and end at 10. And I will check that if number is equal to 7. If this is true, I'm going to break out of this loop. Okay, I'm not going to do anything and the loop will be ended. After that, after checking this, if this is not equal to true, I will check that if the number modulus 2 is equal to 0. This will mean that if the number is even, if this is the case, I'm going to write continue in here. I'm not going to do anything with the even numbers. So I will get to the next one. For example, if the number is 4, it's not going to get into this one. Here, this will be true, and we will use this continue keyword, and it's going to continue with 5. It's not going to do the things after this line for the even numbers. Okay, I will write print number in here at the end. Okay, let's run this and see what you'll get. It started with 1 and this was false and this is false and it printed 1. Then it got to 2, false, true. It executed this continue keyword, so it couldn't print this 2. After this point, it started to loop with the next number, which is going to be 3. For 3, it is false, false, and print 3. For 4, it's going to be false, true, continue. It's not going to do anything with 4. After that, with 5, false, false, print 5. After that, 6 will false, continue, and continue with 7. And after that, when it gets to 7, it's going to break out of this loop and the loop will be ended. We are not going to see anything after this 5. Okay, this is the end of the loops and the control flow statements. Let's start functions. Functions are reusable blocks of code that perform a specific task and they help organizing your code into manageable sections. Functions can take inputs, parameters, or arguments and return outputs, and we will see all about them in this cell. Okay, let's start with the def keyword. Def is used to define a function. Okay, define def and the name of the function, let's say hello. Okay, after that parentheses and a column. And we are going to get into this function with this indentation, and I write print hello world. Okay, this is a basic function, and after that, if I run the cell, as you see, I'm not going to get anything. To make this function work, to execute the line of code in here, we need to call this function. Okay, after defining it, we need to call it by writing its name and the parentheses. And this is all. If I run the cell now, we are going to see hello world in the output. Okay, now let's see functions with parameters. Okay, I'm going to create another function, define greet, and write 2 parameters in here. Those will be some variables that you want. I'm going to write my name, okay, and your name. We are going to send arguments while we are calling this function. Okay, after that, we can use those variables in our function. I'm going to print something. I'll print hello, hello, and after that, you can concat strings like this. Those will be strings, so I will write your name. I'm greeting someone in here, and plus, comma, my name is, plus my name. Okay, this is going to print this one. Let's call this function. I'm going to write greet, and for my name, I will write John, and for your name, I will write Mary. Okay, now if I run this cell, you'll see that hello Mary, my name is John. So those are the arguments when we write when we are calling the function, and they are going to take the place of those parameters in the definition, and we are going to see the string at the end. Okay, now we can get to return keyword. Okay, I'm going to define another function in here. I will call it multiply. Okay, and also I'm going to print a new line at the end of this. I will explain it later. Okay, this will take 2 parameters. The first one is a and the second one is b. Okay, and after that it's going to return the multiplication of those 2 numbers, a times b. Okay, now let's run this function, call this function, and see what you'll get. I'm going to write multiply, and I will put 7 and 5 in here. Okay, let's run this and see what we'll get. As you see, we got nothing after this. I put this print here because if I run it like this, since this is the last thing that we call in here, it's going to show its value. This is a feature of Jupyter Notebook, but actually it's not going to do anything if this wasn't at the last line. Okay, so I will put this print in here. So as you see, when we run this, we are not going to get anything from this function. It is returning something, but it's not going to do anything. It's not going to show anything to us in the console. So this is returning actually 35. Okay, 7 times 5, but we are not using it right now. So we can assign it to another variable in here. Okay, I'm going to write product is equal to multiply 7 and 5. Okay, I'm calling this function with the arguments 7 and 5, and those arguments will the place of these parameters in this definition, and after that this will be 7, this will be 5, and we are going to get 35. And this 35 will be assigned to this product. And after that, if I print the product in here directly, we will see that the 35 is the product's value now. Okay, if a function is returning something, you can assign it to another variable and use it in your code. Okay, after that, let's see another example. Functions don't have to have an output. Here we are returning something, here we are printing something, but some functions may have some functionality, and that is all. There is no output. To show you, I'm going to create a list in here. This will be my list and 1, 2, 3. Okay. And after that, I'm going to define a function and its name will be reverse my list. Okay, it's not going to take anything as the argument also. Just I will call my list dot reverse in here. Okay, this function is special to this list and it is just reversing it. Okay. After this one, my list, I'm going to print it, print my list after defining it. And after the function, I'm going to call it, I'll call reverse my list with the parentheses and print the list at the end one more time. Print my list. Okay, let's run this and see what we'll get. Here we get the list normally 1, 2, 3, and after that we have defined this function, we have called it, it didn't return anything, it didn't give us an output, but if you check my list again after calling this function, you'll see that the list is changed. So without returning anything, without having an output, this function has some functionality. I will end the functions in here. In the mini project we are going to do in the later sections, we will understand functions much better. In this part of the course, we are going to cover error handling, modules and libraries, and file operations. Okay, let's start with the errors. Error handling allows us to manage errors without crashing the program. This is the important part in here. Okay, using try, except, and finally, we can handle exceptions and execute code regardless of whether an error occurred. Okay, let's see how it can be done. I write a try except block in here. Okay, I'm going to try something in this block, and let's write result is equal to 10 divided by 0. Okay, normally numbers cannot be divided by 0, so it's going to throw an error, but we foresee that and we put it in a try except block. Okay, except I'm going to print something. If we got an error in here, it's not going to crash the program, it's going to execute the code in this except block. I write there is an error, but the program did not crash. Okay, let's run this and see what we'll get. As you see, we got this print. Why is that? Because we got an error in here, so the program did not crash. It's going to get into this except and it will print this output. Okay, now let's see what we are going to get if we do it directly in here. Say result, if we didn't use this try except block, result is equal to 10 divided by 0. Let's comment this out for now. Okay, let's run this and as you see, we got an error, 0 division error, division by 0. Okay, let's delete this one and open this comment. After this except, we can also state the type of the error. Let's see another example. I write try, and the thing that I'm going to do is the same. Result is equal to 10 divided by 0 again. Okay, and after that, except, I'm going to write the type of the error directly. I will take it from here. Let's copy this and paste it in here. Okay, now this is going to get into this except block only if this error is occurred. Okay, let's write print cannot divide by 0. Okay, and after that, let's see the finally keyword. Finally, it's going to be executed whatever happens. If you get an error or not, this finally, the code in this finally block will be executed at the end. Okay, print execution finished. Okay, now let's run this, and this time, as you see, this is from the upper part. We will get into this cannot divide by 0, the 0 division error. It's going to print this one, and whatever happens, it's going to execute the code in this finally, and we are going to see this in here. If you do it this way, if you state the type of the error, The program will crash if you get some other kind of an error. Okay, it's not going to get into this except, for example, I write x is equal to p in here. Okay, we haven't defined anything as p. So if I run this program will crash and it will give us a name error. Name p is not defined. Okay, solve this. You can also have another except in here. You can have multiple excepts. And with this except, I'm not going to state anything. I will not write name error. This is going to be a general except and it's going to print some other error. Okay, if I run this, we are going to see that it will print some other error and after that it's going to print execution finished. Let's see modules and libraries. Python has standard libraries and third-party modules. You can import these modules into your script to use pre-written functions and classes. Okay, let's start with the standard built-in libraries. We can import them directly, but for those third-party modules, they need to be installed first using pip. Okay, let's start with the standard built-in libraries. I will import math library. Okay, I will directly write import math. Now we have imported it and we are going to use its features. Okay, I'm going to take the pi value from this library. Pi value is equal to math.py. Okay, if I print it, we will see that we managed to reach the pi value in this library. Let's run this. And as you see, we got the pi value from this math library. Okay, you can also import directly this pi. And to do this, you will write from math import pi. Okay, and after that, you don't have to write math at the beginning of pi. You can just write pi in here. Okay, if I run this, I'm going to get the same result. Let's see another built-in library. I will say from datetime import datetime. Okay, this is used like this, and this is a commonly used one. Okay, now I'm going to take the current time from this library. Okay, we have imported datetime attribute from this datetime library, and I will take the current time. Current time is equal to datetime, the name of the thing that we have imported, and after that dot now. Okay, with this method we are going to see the current time in here. Okay, I will print it. Current time. Okay, let's run this, and we are going to see the current time up to the milliseconds in here. Okay, now let's see how to install a third-party library. I'm going to do it from the command prompt. If you are using PyCharm, for example, you can do it you can do it from the terminal of PyCharm. I will open the command prompt, and from here I will write pip install pandas. Okay, I will install the pandas library like this. Okay, I have already installed it, so it didn't take any time for me. Okay, let's close this one, and now we can import it. I will import pandas, and you can import it using another name. Okay, we are going to refer to it as pd after this. Okay, now we can use it. I'm going to create a dictionary in here, and the dictionary's first key will be names, and the value will be a list. Okay, I'm going to write some names in here, and after that we are going to convert this to a pandas data frame. You'll see that. Okay, the first name is Alice, and the second one is Bob, and the third one will be Charlie. Okay, after that the second key value pair key will be score, and scores of those people are 85 for Alice, 90 for Bob, and 95 for Charlie. Okay, after that I'm going to create a variable called df data frame. This will be equal to pd pandas. We are going to use it as pd dot data frame. Okay, and I'm going to put this data dictionary in here. Okay, if you do it, you can convert a dictionary to a data frame, to a pandas data frame. Okay, and after that I'm going to print it, print df. You don't have to understand pandas in here. I'm just showing you an example of a third-party library. Okay, let's run this. It will take a little time. What is wrong in here? Module pandas has no attribute data frame. I think we made a typo in here. Okay, this F should be uppercase. Okay, let's run this one more time. And as you see, we have a data frame in here. We use pandas library to convert this dictionary to a data frame. Okay, now let's see the file operations. Working with files is a common task in programming. You can read from and write to files using Python. Let's see some examples of it. I write with open. This is the common usage. And here I write the name of the file, output.txt. Okay. And after that, I will put a comma and write W in here. So I'm going to open it in W mode, in writing mode. Okay. If there is no file as output.txt, it's going to create it. If there is such a file, it's going to override it. Okay. After that, I write as f. Okay. So we can refer to it as f in this with open. Okay. I will get into this, and after that, I write if f.write, and let's write Python programming is powerful. Okay, it's going to create this file, and after that, it's going to write this to this text file. Let's run this. We are not going to see anything in here, but if I open this directory, if I wait a little, okay, this output.txt file is created. If I open it, I will see that Python programming is powerful. Okay, now let's read from this file. I'm going to use the same method with open. I write output.txt. It's going to be the same file. I'm going to read from it this time. So the reading, the mode will be reading mode. I'm going to write R in here. Okay, and after that, I will write as f again, and I will create a variable as content in here. Content is equal to f.read, and this will be all. If I print this content at the end of the cell, content, okay, let's run this, and this time we will see this in here. We have created this file, write this to this file, and after that opened it in reading mode, read it, we have read it, and after that we have assigned this value to this content, and now we can see it in the console. Let's see writing to an existing file with open, and this time the mode will be different again. Okay, I write output.txt, and the mode will be append. Okay, as f again, and in here I write f.write. Okay, the name of the method will be the same with this one, but this time we are not going to override it. We are going to append to it. I write, I will start with a new line, \n. This is a special character. If you put it to the end of this one, the things that you write after this is going to be in the next line. Okay, I write and I love it. Put the exclamation mark in here. Okay, let's run this and see what we'll get. It's not going to be changed because we are reading the content from here. We have not appended yet. But if I open this output.txt file, refresh it, you'll see that and I love it is appended to the end of this text. Let's also read this one. I will copy this and paste it in here. After appending and I love it at the end, I'm going to read it and I will change the name of the variable as content end. Okay, if I run this, we will see that this is coming from the first print and this is coming from the second one, content end, and we can see that and I love it is appended at the end of it. This is the end of file operations. In this part, we will see strings in more detail. Strings are sequences of characters. They are used for handling text and they can be manipulated, but this doesn't mean they are mutable. Okay, let's see some examples. I will create a variable called message in here. Message is equal to this string hello world. Okay, this is the message. And after that, I will create another one as name in here. Name is equal to, let's say, Sam. Okay, those are two examples of strings. Now we are going to use them in this basic concatenation. Okay, I will create another variable called full message this time. Full message is equal to, and we are going to use the plus operator to concat those strings. And I'm going to put some other texts between those. Okay, I will start with the message. This will be hello world, and after that plus I'm going to leave a white space in here, and I write welcome, and after that I'm going to put the name in here. Okay, this will print hello world, welcome Sam. Okay, let's put an exclamation mark also at the end of this. Okay, now let's print this one, print full message. If I run this, I will see hello world, welcome Sam. Okay, this is how to concat strings in the most basic way. Okay, now we are going to see string formatting. This is the best and most practical way of formatting or concatenating strings. I will create another variable called formatted message. Okay, this will be equal to, I'll start with f and open quotes after that. Now this is a formatted string and we can open braces in it and put the variables like this. I'm going to put the message in here and after that I will get out of the brace and I can write a normal string after this. We do not have to write any plus in here. I'm going to write directly, how are you? Okay, and after that let's open another brace and put the name in here. And just after this one, I'm going to put a question mark. Okay, this is all. Now, let's see what you'll get from this. I'll print this formatted message. And if I run this, as you see, hello world from this one, and how are you, and the name in here. Okay, this is very practical. And you most probably, if you continue with Python, you will use this a lot in your codes. Okay, let's get to the common string methods. Python provides several built-in methods for manipulating strings. These methods include changing case, trimming white spaces, and replacing substrings. They do not change the string, they just return a changed version. Let's see what I mean by that. I'm going to create a string in here, I will call it text, and I will start with some white spaces, and after that I will write the string, I will write the text in here, Python programming, okay, and put some other white spaces at the end of it. Okay, now I'm going to apply some of the most commonly used string methods to this text. Let's call text.lower. This is going to change all the characters to lowercase. Let's print it. Print the text. If I do this, I'm not going to get anything. Why is that? Because, as I said, strings are immutable. They are not changeable. So, calling methods on them will not change the original string. It's just going to return a changed version. So I'm going to assign this to another variable. I will call it changed version is equal to text.lower. And if I print this one in here, this time I will see the effect of this text.lower. Okay, it is Python programming all in lowercase. Okay, let's delete this one and actually let's print this directly. I'm going to do it for the other methods. Let's put this in a print statement. And by doing this, it's going to return the changed version and it's going to be in this print statement. So if I run this, we are going to see the changed version directly in here. Okay. Now let's call another one. This will be text.upper. As you'll guess, it's going to change all the characters to uppercase. If I run this also, you'll get uppercase Python programming. Okay. Let's see another one, text.strip. Okay, this is going to delete the unnecessary white spaces and the new lines at the beginning, at the end, and at the end of the string. So it's going to delete those at the beginning and at the end. Okay, let's run this. And you'll see that the ones at the beginning are gone. And also the white space at the end are gone, but we cannot see them. Okay, let's see another one. I will print text.replace. And this will take two arguments. First one will be the thing that you want to change from your string. I'm going to write this programming directly in here. You shouldn't make any changes. You should write directly the thing in your string that you want to change. Okay. And after that, the second one will be the new value. I'm going to write coding in here. So if I run this, I'm going to get Python coding rather than Python programming. After all, let's print this text again and see if anything has changed. Okay, print text. If I run this, we are going to see that nothing has changed. It is still the same at the beginning. Okay, after all those methods, the text is still the same. Now finally, I will show you my favorite string method and it's going to be split. I will create another string in here. I will call it new text and it's going to be equal to, let's take this sentence from here. Let's copy this and paste it in here. Okay, after that, print new text dot split, and we are going to write a separator in here. Okay, I write white space. Okay, I'm going to put a space in here. So this method is going to split the string using the white spaces and it's going to return the list of the items. Okay. If I run this, as you see, we got this list and they are separated from the white spaces in this text. If you don't write anything, it is using the white spaces by default, by the way. Let's run this and we will get the same result. Okay. But if you write, for example, this is the most common use case using the white spaces, but you can put some other thing in here as the separator. If I put this dash, okay, let's put the dash in here and run this. This time, since there is just one dash, it's going to divide this to two and we are going to get a list of two items. First one will be this and the second one will be this one. Okay, let's run this. And as you see, the first element of the list and the second one. And as you have noticed, it is going to delete the separator. It's not going to include it to any uh, item in the list. Okay, the separator will be deleted at the end. Okay, this was all for strings. In this part, we will have a mini project and we are going to create a to-do list application by applying the things that we have learned until now. We will start with an empty list and there will be a function to add a task, a function to list all the tasks, function to complete a task and remove a task. At the end, we are going to call those functions and see the outputs. Let's start with the function to add a task. This will be very simple. After creating the empty list, I will define def add task. Okay, this will be the name of the function and it will take an argument called task. This is going to be a string and this will be a list of strings. Okay, inside of this, I will use the append method to add the task to the end of this list. To the list dot append and put the task in here. Okay, this will be all actually, but after that I want to print something to the console to inform the user. I will use an f string with double quotes and inside of it, inside of single quotes, I will open braces and put the task to emphasize it. Okay, and after that I will call task is added. Okay, and this will be all. Let's call this and see what it is going to do. I'll call add task and write go shopping in here as the task. Shopping. Okay, and after that let's print the to-do list. Okay, I will call this and as you see, we see that go shopping task is added. We are emphasizing it with the single quotes in here and now our list has one item in it. We successfully added this using the add task function. Okay, now let's see this one, function to list all the tasks. Define list tasks. Okay, it's not going to take an argument. And inside of it, the first thing I will do is to check that if the list is empty. If it is, we are not going to list anything, of course. So I will check that if the length of the to-do list is equal to 0. If this is the case, this will mean that there is no item in this list. So I will write no tasks in to-do list. Okay. But if this is not the case, if there are some items, we are going to print them. And to do this, I'm going to use a for loop. Okay. For task in to-do list, I will print the task. Okay. But this is very simple. Let's make it more beautiful. I'm going to also number those tasks. Okay. To do this, I will take this to-do list and inside of parentheses and write enumerate in here. Enumerate. And after that, after using enumerate in here, you can use the index of the item also. So I can use this I and task as the item itself in this list and also the index of the item in this list. Okay, this enumerate does that. And inside of this print, I will use an f string. Okay, I will start with some blank lines. And after that, first I will write the number of the item in the list. And since the indexing is starting from 0, I'm going to increase the index by 1. I plus 1. And after that, I will say the first task is, let's open another braces in here, task. Okay, we will see this in the console in a moment. Okay, this is how to list tasks. Now we are going to call this Now let's also add another task to this list. Add task. Let's say do laundry. Okay. And after that, let's delete this because we have a function to do this right now. After creating this def lists and also after adding those two things to the to-do list, I'm going to call this list tasks. List tasks. Okay. And this will be all. Let's run this and see what we'll get. As you see, we are seeing those two lines because they are coming from this function. Okay, we are calling this twice, and it's going to print this twice. And after that, by calling this with this loop, we'll see that first go shopping and second do laundry, and it is done as this one. Okay, like this. We are using this print statement and we are using the index of the task. We are increasing it by 1 to see the number of the task in the list, and after that we are writing the name of the task directly. Okay, now let's delete this and see our next function. Okay, now we are going to create a function to complete a task. Def complete task. Okay, this will take an argument and it will be the task number. The number that we see when we list the tasks as 1, 2 in here. For example, if we write 1 in here for the task number, it's going to delete this go shopping. If I write 2, it's going to delete this laundry. Okay, after that, we are going to check something. The first check will be if the task number is greater than or equal to 1. Okay, task number, if this is valid. And after that, I'm going to check another thing, and I will check the length of the to-do list. If it is an empty list, we are not going to do anything. If the length of the to-do list is not equal to 0. Okay, if both conditions are satisfied, we can get into this and we are going to complete a task. We are going to delete it basically, and we are going to print something to the console. Okay, I will take the completed task first from the list. Completed task will be equal to do list, and I'm going to write the index of the task in here. What is going to be the index? Index is going to be task number minus 1, right? Because we are increasing the index by 1 in here to use it as the task number, and in here we are going to take it and decrease it by 1. We are going to subtract 1 from it to reach the index of it, and when we call this with the index, we are going to get the item that's going to be deleted. Okay, the completed task will be this, and after that we will call the remove method to do list dot remove and put the completed task directly in here. Okay, after that we are going to print something. I'll print an f string again. Okay, let's write braces. I'm going to write the name of the task, completed task in here, and after that has been completed. Okay, this will be all. After that, else I will say if this condition is not satisfied, we are going to get into this else statement, and we are going to say that invalid task number, or there is no item in the list. Okay, this will be all. Now let's call this after adding those two tasks. First, I will call the list task in here. List tasks. See the items in the list. Let's call this one first, and we are going to see the same thing. Go shopping, do laundry, and after that, I'll call complete task, and I'm going to delete this go shopping. Okay, I will write 1 in here as the index, and after that, I will call list tasks one more time. See if we have deleted this go shopping. Okay, let's run this. And as you see, this was the list at the beginning. After that, go shopping has been deleted. Now our new list is this. There is just one item. And as you see, the index has changed. Index 1, the number 1 go shopping is gone, deleted. And do laundry is the number 1 from now on. Okay. Now let's see the function to remove a task. This is going to be the same actually with the complete task, but this print statement will be different. Let's copy this and paste it in here. I will change the name of the function to remove task. Let's also change this one to removed. Let's copy this, paste it in here, also in here, and has been not completed, removed. Okay, the functionality will be the same, but the print statement will be different. Okay, now I'm going to delete all the function calls. Okay, and I will call them at the end of the cell as an application. Okay, let's also delete those. We have 1, 2, 3, 4 functions. Now let's call them. Let's run this cell first to clean the output, and after that, let's start calling those functions. Okay, first I will call list tasks. Okay, if I call this and run the cell, we will see that no tasks in the to-do list yet. Okay, let's delete this. Let's comment this out. And after that, I will call add task. Let's add go shopping again. If I run this, we'll see that go shopping task is added. After that, I will add 2 more tasks. Add task, study for exam, say. Okay. And after that, add task. Let's add clean the house. If I run this, we'll get those 3 lines, and we have added those 3 tasks to the to-do list. Let's check it. I'll print something. Print at a new line, and I write to-do list. Okay. After that, I'm going to call list tasks again after adding those 3, and let's run this and see what you'll get. As you see, we got the list of those 3. 1, 2, 3, go shopping, study for exam, and clean the house. Okay. After that, let's complete one. I'm going to print something first at a new line again using those backslash and n special character. I'm going to leave one more blank line between those, and I write complete second task. Okay. After that, I write complete task function, and write 2 in here. Okay, it's going to delete the complete the second task, so study for exam will be completed. After that, let's take the list of the tasks again. These tasks. If I run this, it will say that complete second task, study for exam has been completed, and now we have go shopping and clean the house. As you see, the clean the house was number 3, now it is number 2. Okay, and after that, finally, let's call print at a new line again, remove first task. Okay, after that, let's call the remove function, remove task. I will write 1 in here, so this is going to delete this go shopping from the list. After that, I will take the list of those again, list tasks. Let's run this, and as you see, remove first task, go shopping has been removed, and now we have just cleaned house in the list. Okay, this is all for this mini project. In this part, we will make a brief introduction to object-oriented programming. We will see classes and objects, and inheritance and polymorphism, which are the 2 main concepts of object-oriented programming. Okay, OOP uses classes and objects. Classes define the structure and behavior of objects, and objects are the instances of the classes. Object-oriented programming helps in organizing code and managing complexity. Okay, let's start by defining a class. The class name will be animal. Okay, class names are starting with uppercase, and after that I will put colon and get into this class. The first thing I'm going to create is the init method of the class. This is a special method, and it is defined like this. I write def double underline init and double underline again, and in this init method there'll be a self keyword, and after that I'm going to put 2 attributes to this animal class. Okay, the first one will be species, and the second one will be the name of the animal. Okay, If you get into this init function, init method, I will write self.species is equal to species and self.name will be equal to name. Okay, this is telling the program that when you are creating the instance of a class, you are going to take those two attributes, okay, species and the name, and you will assign them to the self attributes of the class. Okay, we will see how to create an instance of the class. Now let's create a method, class method. I'm going to call def, and this will be a normal method. I will call speak. Okay, and this will take just the self keyword. And after that, I'm going to return something from this method. Let's return f, an f string, and this will start with the name of the animal, self.name, and after that makes a sound. Okay, this will be all. Now this is a basic class. Now I'm going to create an object using this class. Okay, this is going to be an instance of the class. I'll call it my cat. And this will be equal to, I will write animal, the name of the class. And after that, I'm going to write the two attributes that I have defined in the init method. Okay, this init method will be called automatically when you are creating this class. And it's going to take two arguments, in this case, species and name. I will write as the species cat. And the name of the cat will be, let's say, grape. Now we have created an instance of this class, and this myCat variable is now an object created using this animal class. After creating it, after taking the instance, we can access its attributes and methods using this variable. Okay, let's do this. I will print something. Print myCat dot species. Okay, you can reach the attributes like this. You can put the dot, and after that write the name of the attribute. And if I run this, you'll get cat from here. And also I will print my cat dot name. If I run this, I will get grape that we put while we are creating the instance. And also we can have some default attributes. Okay, let's do it like this. I'm going to write self dot color in here, the color of the animal, and this will be equal to black. Okay, this is a default attribute. We are not taking it in this init method. We are not putting the attribute while we are creating the instance. This is a default attribute, and we can also reach to the color of the animal. I'm going to delete this, but I'm going to show you how it is done. My cat dot color, and if I run this, I'm going to get black by default. Okay, let's delete this one. Okay, after that we can also access the methods in this class from this myCat object. Okay, myCat dot speak, if I call it like this, and you need to put parentheses at the end of it to call this method. Okay, if I run this, I'm going to get grape makes a sound. Okay, this took this grape name when we create the instance, and it assigned it to this self.name attribute of the class. After that, in this class method, it used this self.name to create this expression, and for this myCat object, it will always be grape makes a sound. Okay, if we create another instance of this by putting some other names and species in the animal while in the init method, it's going to behave different. This self.name will be different. So when we call speak from the other animal, it's going to give us another output. Okay, now let's see inheritance and polymorphism. Inheritance allows a class to inherit attributes and methods from another class. It provides code reusability and establishes the relationship between classes. The new class, which is going to be called subclass or child class, can override the functionality of the existing class, which is base class or parent class. We will have an example and you will understand what I mean better. And polymorphism allows methods to do different things based on the object, so the methods will be the same, the names of the methods will be the same, but they are going to behave different based on the object that we are going to call them from. Okay, let's start by defining the base class. Let's call it class animal again. Okay, and create the init method, def init, double underline, and it will take self. I will take two attributes again. This time they will be name and age of the animal. Okay, after that let's assign them to the class attributes by calling self.name is equal to name. and self.age is equal to age of the animal. Okay, we are going to take the name and the age while we are creating the instance, and we will assign them to the class attributes to use it in our code in the class. Okay, in the class methods. Okay, I will create a class method and I will call it make sound. Okay, this is going to take no arguments, just self, because this is a class method, and I will just pass this for now. Okay, it's not going to do anything for now. We will see why we are doing this in this way later. Okay, let's create another class method. I will call it info. Okay, this will also take just self, since this is a class method, and I'm going to return an expression. I will write an f string again. Okay, let's put the name in here. Self.name is, I'm going to write the name of the animal and the age of the animal. Self.age years old. Okay, this is going to be the expression. Now let's create the subclasses. I'll start with class cat. Okay, and to inherit from this animal class, I will write animal after the class name into parentheses. Okay, this is how to inherit from another class. And after that, this cat class will have all the methods and the attributes of this animal class, and we can make adjustments on them. I'm not going to do much thing in here. I'm just going to change this make sound method. Okay, I will write def make sound. I'm going to define it one more time with the same name, and it's not going to do anything, take anything. It will take just self, since this is a class method. And after that, I will return. I will not pass this now. I'm just going to return meow. Okay, this will be all, and we are going to do the same thing for class dog and class cow. I will copy this and paste it in those places. Okay, after that, let's take this dog, copy and paste for the name of this cat and cow, and change the sounds. For dog, I write woof, and for the cow, I write moo. Okay, now we will create the instances of those classes, and I will explain inheritance and polymorphism on those instances. Okay, let's start with the cat. I'll call it my cat again, and this time this will be not animal, cat directly. Okay, and we can use the init methods of this animal class since we are inheriting from it. Okay, this is the inheritance. Okay, we didn't have any init method in this cat. We didn't write any init method in this cat class, but since we are inheriting from this animal, we are going to use the methods and the attributes from this animal class. Okay, this is inheritance. So I'll write Maya in here as the name of the cat, and the age will be 3. Okay, let's do the same for the dog. Dog is equal to dog plus, and the name, let's say Oldie, and the age will be 5. Okay, let's create my cow finally. My cow is equal to cow, and the name will be Bessie, and age will be 2. Okay, as I said, we can create those instances of the cat, dog, and cow classes using the init method of the animal class. So this is an example of inheritance. Okay, now let's see some other things in here, accessing the attributes and the methods. For every instance that we have created, I'm going to call 2 methods. The first one will be this info method that is going to inherit from this animal class, and the second one will be the make sound method. It was in this animal class at the beginning, but when we create the instances, we have modified it for the different types of the classes. Okay, let's do this. I'll print my cat dot info. Okay, let's call it with the parentheses, and after that I will also print my cat dot make sound. Let's copy this, okay, and paste it in here and also in here, and change this to my dog, and change this to my cow. Okay, I'll print some new lines at the between them. Let's copy and paste it in here. Okay, now let's run this and see what we'll get. As you see, it says Maya is 3 years old from this info method. Baldi is 5 years old and Bessie is 2 years old. So this is another example of inheritance Since even if we didn't create any info method in those classes, it is using it from the parent class. So it is inheriting this info method and using it in the subclass, in the child class, like this. Okay. And with the make sound method, we are calling the same method from those different objects. And as you see, even if the name of the method is the same, the output will be different. Okay, they are behaving differently. And this is the example of polymorphism. Okay, the names of the methods are the same, but they are behaving different uh, since we are calling them from different objects. Okay, this was a brief introduction to object-oriented programming with Python, and this is the end of it. We are concluding our quick Python course in here. I hope I could help you to create a foundation for your later studies. I wish you the best. Bye.